So, good morning to all once again. So, today we'll be discussing about stepper motor interfacing. So, before going to stepper motor interfacing, let us have a small introduction about motors and then we'll proceed. So, basically, what do you mean by a motor? What is the function of a motor? What do you mean by motor? So, first we'll just see what is meant by motor, then we'll discuss about what is stepper motor. See, am I audible or not? Why there is no response? The question was so simple. What is a motor? Yeah, very good. So it's an converts Ujala and Varshini. Thank you. So device which converts what? Electrical energy into mechanical energy. So which means electrical energy will be converted into some rotational motion. So that's what we have. People would have studied in basic BEEE. Probably, I guess. So what are the main components of a motor? No need to tell all the parts. Just you can mention the main components are required in a motor. What are the main components of a motor? Yeah, very good. Superb. So rotor and stator. See, I was expecting these two only. So we usually have what two main parts. One we call it as rotor, other one is called stator. Fine. Okay. So you are familiar with these two also. And last question from my side. And what is the difference between these two parts? Or a major function? You can just state the major function of a rotor and stator. That's enough. And rest I will proceed. What is the main function of a rotor? And similarly, what is the main function of a stator? Yeah, very good. Again, I got the required answer. That's what I was expecting. So, though there are many other functions, I was expecting the same one. So, rotor is a rotating part of your motor. We call it as rotor. Okay, name itself indicates rotor. And stator is something but stationary part of your what? Yeah, very good, Varshini. It's correct only. So, stationary part of your motor. So, if we take any motor, we'll be having what? Two components, motor and rotor. Okay, fine. And then hope you would have studied what are different classifications of rotors, AC motors, DC motors. Again, in AC and DC, you would have studied quite a lot of motors. So we're not going to go in much in detail about those types. So I think there itself we had a chance to go have a study about stepper motor, I guess. Sure, I think yeah, you had in syllabus stepper motor. So what is a stepper motor? Any idea what is maybe stepper motor? Have you ever seen these motors anywhere? Obviously, you would have seen these type of motors in many places. Yeah, very good. Brushless DC motor. So it's one category, brushless DC motor. So all this comes under type called hybrid motors. So anyway, so this is nothing but a small few view of your stepper motors. And here is one example given is a drone cameras, drone. So we normally use what stepper motors. Not only in drones, we have a number of applications where we use these stepper motors. Let's have a look at it. Where and all we use these stepper motors. So stepper motors, when compared to other motors, no, stepper motor is more popularly used, especially in computer peripherals. It is used in plotters, robots, even in robots, widely used. Stepper motor has been widely used. And so in some industrial, if we take industrial applications, no, wherever there is a very precise, what to say, incremental rotation, wherever there is a need for any precise incremental rotation, obviously your stepper motor will comes into picture. So we call it as mostly call it as machine tools. So these machine tools, no, where your precise incremental rotation is required. Again, the stepper motors plays a major role. It is widely used. Okay, and in case of robots, as I said, another example, it is used in robots. So it is normally used in in position control of your robot arms. So mainly in position in robot arm rotations, no, this is really used. And paper down mechanisms in a printer, if you have noticed, and even in process control systems, it is used. Textile industries, even in IC fabrication, integrated circuit fabrication, no, these type of motors are used. There is a need. Electrical watches, tapes, even as well as your disk drive systems. So all these places, okay, where we have n number of applications where we can state what these motors are used nowadays. Okay, the main reason, what could be the main reason? In almost all the applications which I listed, no, there is something common. If you identify it, that will be the reason for it actually. So because wherever we need a very small incremental rotation, okay, in those places we go for only stepper motors. Okay, so these are the examples, and then other reasons apart from this small incremental rotation, no, there are some few other reasons why we go for stepper motors. Simple to construct, reliable. So at standstill condition, what the motor has full torque. So you know what is the role of torque in case of your motors, okay, and economical. So require less maintenance since it is simple in construction. Obviously, what will requires what little maintenance, and moreover, no, the stepper motor has one of the main advantage of using stepper motor is we have you can use this motor for both forward and reverse directions. Okay, so these are few advantages of stepper motor, and followed by they have few drawbacks we can say for stepper motor. So normally, stepper motor uses more current when compared to normal standard DC motor. So current consumption is quite high. So what happens? So obviously, when high speed, what will happen means you cannot able to control. That is a major drawback here. Speed control is not possible, and then also at high speed, or apart from speed control, your torque value also reduces. So obviously, what you will be having a lesser efficiency. Okay, and these are a few drawbacks of your stepper motor. So these are just a view of your stepper motor, how a stepper motors will look like. Hope you know what is this. So this is called as what a stationary part, which usually normally called as stator, and in between will be having your rotation part. And what is this? Something pulse-like structure. So even in this diagram, you can see clearly. This is in between we have rotor, and this is going to be what status. Okay, here in this place inside the rotor will be having your stator, and okay, fine. So as I said previously, any motor will have what two windings, stator as well as what rotor. So in case of a stepper motor, so normally the stator windings, it will be excited by your electrical pulses. So and for each pulse like this, so that's what I have represented here. It has been represented here. So for each pulse, the motor shaft will advances by one angular step. You got my point. So here we are not going to give. See, normally what happens means if you take a general motor, you'll be having as usual stator, rotor will be having. So in a rotor, will be having, sorry, stator will be having field winding. It will be excited with, will be giving excitation. So it may be AC excitation or DC excitation. Depending upon type of excitation, you'll classify it as either AC motors or DC motors. Fine. But here, no, I'm not either going to give your AC supply or neither your DC supply. Instead, I'm going to give you what pulses, electrical pulses. And for each pulse like this, and for each pulse which I'm going to apply to your stator motor, the motor is going to get advanced or rotated by one angular step. I'll tell you what is meant one angular step. Okay. So since the stepper motor is driven by these type of your digital pulses, it is widely called as what? Digital motor. Okay. So normally stepper motor is also called as what? Digital motor. The reason is this. The reason is what? Since it is driven by what? Digital signal, we call it as what? Digital motors. Okay, not so stepper motor, digital motor, both are same. Okay, fine. Okay, so and the step size, the angular step size, usually it is determined by number of poles available in the rotor. The step size, as I said, it will be rotated by one angular step. No, the step size in the motor is normally it is determined by a number of poles that are present in a rotor, and also number of pairs of stationary stator windings. Okay, so I think hope you may remember what you are studying construction of a normal motor. So normally one pair of your stator winding we call it as what? One phase. One pair of stator winding we call it as what? One pair. So since you are going to excitation is applied to your water stator windings, we also call it as what? Control windings. The stator windings are also called as what? Control windings. Okay. So normally we'll give excitation to your only your control windings, not your field. Sorry, rotor. Okay. So here, no, why we call it as control windings? Normally the motor, no, it can be either controlled by switching on or off the control windings. I mean your stator windings. Okay. So normally, most popularly, we use stepper motor. No, it will be used in if you go for laboratories, any laboratories. No, you will be having a step size of 1.8 degrees, which means what? 200 steps per revolution. I'll tell you how I got this 200 steps per revolution. Okay, we have small formula to calculate. So this is the most popularly used stepper motor, 1.8 degrees. So approximately 200 revolutions, steps per revolution. Okay. So basically, if you take a motor has 4 stator windings, we'll be having 4 stator windings. So we have a diagram I'll show you. We'll be having 4 stator windings and requires what? Obviously, it requires what? 4 switching sequences, because we have 4 stator windings. Obviously, we need to excite them. Excite means nothing but we have to provide them with supply. So which means here we need what? 4 switching sequences. So we'll see what are the sequences, how we are going to apply for these 4 stator windings. And the basic step size of a motor, we call it as what? Full step. The basic step size of any stepper motor, we call it as full step. And it's by altering your switching sequence, the motor, you can make it to run with any incremental rotation of half the full step value. This is nothing but you call it as a half step rotation. So we have 2 types of rotations: full step, half step. Okay. So normally, as I said previously, it will be having 4 windings, and a Darlington pair transistor will be provided for each winding. And this transistor pair is made. The purpose of this Darlington pair transistor is to control the current flow through the windings. So whenever transistor is going to be on, current will flow through the windings. And whenever the transistor is going to be off, no, there will be no current will flow through the windings. Okay. So the windings of this normal stepper motor, they connected to collector. I think hope you know that transistor at least. So you may not know much about your Darlington pair, but at least you can know what is meant by a transistor. It will be basically it will be having 3 components. You remember what are the parts? What are the terminals? You don't call it as components. We call it as terminals. What are 3 terminals of a transistor? I think it's a basic question. 3 terminals you have in a transistor. Any idea? Base, collector, and emitter. Okay, so these are the basic terminals you have in a transistor. Okay, so the windings of this stepper motor are usually they are connected to collector of your Darlington pair transistors, and the transistors can be either switched on or off by the microcontroller through port 0. That we can simply applying a low or high to the base of the transistor. Okay. And apart from this, we have a freewheeling diode. It will usually be connected. I'll show the diagram and I'll explain you where these Darlington transistors are available, as well as your freewheeling diode is connected. Okay, we have a freewheeling diode. It is usually connected across each winding. So this purpose of this diode is used for what? Fast switching. Okay, and collector. Sorry, and we'll be having controller. The controller has to output a switching response and wait for what? Minimum of 1 to 5 milliseconds before sending the next sequence. Okay, and actually the delay is necessary because now we will be having transients. So I think hope you know what is known transient. So basically we'll be having delay. So delay is needed to allow the motor transients to die out. So once it is die out, you can able to what make the descend the next sequence. Okay. So first we'll start with working. So I think so far we have seen construction of your motor. So what is a stepper motor and what are the main parts we have? So basically, stepper motors we call it as electromechanical devices. So as a name indicates, what all are electromechanical because it converts electrical to mechanical. So we call it as what electromechanical devices. Nothing new. So basically, which means what? Why I call it as electromechanical means here, especially it converts what your stepper motor convert your electrical pulses into corresponding or proportionate to what mechanical rotation moment. So discrete mechanical, I call it a discrete. You have to remember that word. So I repeat, stepper motors are electromechanical devices which converts electrical pulses into proportionate discrete mechanical rotational moment. Okay, and apart from that, to rotate the stepper motor shaft. So I said we have a sequence of pulses is required that has to be applied to your what your control windings or stator windings of your of your stepper motor. So when a given number of command pulses are usually when supplied to the motor, the shaft will have turned through a known angle. That we call it as what? Step angle. Okay. So the motor can be used to control position by keeping the count of number of your command pulses that you are going to apply. And each revolution of the stepper motor's shaft will be made up of a series of discrete individual steps. So when you say step means it's nothing but angular rotation produced by the shaft each time when the motor receives a pulse. That only called as what? Step. A proper definition for step. Okay. So I repeat, a step is defined as angular rotation produced by the shaft each time when the motor receives a step pulse. So whenever each time when it receives a step pulse, the shaft will rotate, and that rotation only called as what? Step. Okay, angular rotation. Fine. So due to each step, the shaft can rotate only specific angle in terms of degrees, and that rotation of shaft due to each step we call it as what? Step angle. So that only called as what? Step angle. Okay. And the stepper. Okay, fine. So we'll see how to calculate the step angles. And one more point you have to remember that the average motor speed in case of your stepper motor will be proportional to rate at which the pulse command is received. Okay, I repeat, the average motor speed, stepper motor speed will be proportional to rate at which the pulse command is delivered. Suppose in case it is a low command pulse rate means the motor moves in step, but when the pulse rate is if we are making it sufficiently high, so obviously what because of inertia the rotor it moves smoothly as in the case of a normal DC motors. Okay, fine. So so you can kind of summarize that what a step as motor speed is proportional to rate of command pulses, it can be used for step control. Okay, so in that way you can able to control the speed of the motors. Okay. Stepper motors. So I think it can also called as as I said, stepper motor also called as digital motor. Another name also we can use stepping motor. So as the name indicates, stepper motor or stepping motor, which means what? So rotor movement will be in the form of what? Discrete steps. Okay. So we call it as what? stepping motor also. So depends. So different names we have. Okay. Yeah. So this is a view of your stepper motor. So totally, how many poles are there? How many stator rotors are there? How many poles are there in the stator? Any idea? You can have a look at the diagram and then you can say how many poles are there. Two. You mean two in the sense saying whether it's in terms of pairs? Yeah, North Pole and South Pole. Fine, very good. So how many windings? Two poles is correct. How many windings are there here? Yeah, very good, excellent. So here we have four windings. So because in each pole we'll be having a winding. Okay. So one, two, three, four. So we have four poles. Obviously, in all these poles there are windings present. So here you can only have a look at it. So here we have winding, here we have winding. So all these poles we have winding, and these two pair normally we call as together we call as what I said. I don't know whether you remember not. One pair, one pair of stator winding together we call as what one phase. Okay. Similar. So which means we have to do. If we say in terms of pair, we have two pairs, or we have four windings. Okay, fine. So simple, and this is your view where you can these parts are stationary, and this is in middle part we call it as rotational part, which is we call it as what rotor. Okay, and stator windings are control windings, which we are talking about. No, it will be wounded on here. So on these four poles, it will be wounded, and it will be excited by pulses, electrical pulses. Okay. And there is a principle of operation of your motor. So each motor will operates on certain basic principle, and stepper motor works on the principle of what magnetic attraction and repulsion. PMMI instruments. Hope you would have heard of this. Okay. So obviously, what happens means, as I said, what here will be having stator windings in all these poles, and when the stator windings the coils are energized, so what happens and there will be say these coils they are wound on electromagnets. Obviously it will be having electromagnet, and it will be coil windings will be wound on these electromagnets. So whenever the pulses are received, it will be energized and de-energized takes place. So it will creates what magnetic north and south force of attraction or repulsion depending upon the excitation that you're going to apply. Okay. And we'll be having a rotor is usually mounted in between on a permanent magnet, having a permanent water north and south poles. Okay, and the rotor will be in between these two normally. Okay. And this is a small. You can have it just look at it. So just have a look at it and let me know what is actually happening here. Any idea have you got? So what's happening here? Small animation. What do you observe actually? Rotation, very good. So rotation taking place. Okay, and then what else? So how is rotation taking place? If you have noticed, means rotation takes place in steps, in a very small incremental rotation only. So that only called as what step rotation. Okay, and the angle to which the step rotation takes place, we call it as what step angle. Okay, or step size basically. Clockwise, yeah, very good. So you can either make it rotate clockwise as well as both anti-clockwise is also possible. So now in this case, if it is rotating from forward direction, so just by reversing the sequence, the electrical pulse sequence, you can make it rotate in what reverse direction. It is also possible. Okay, reverse connection. So, okay, everything you are able to guess, but what happens actually here? So here the diagrams shows we have a four-phase stepper motor windings. So we'll be having, for example, like there is windings 1 and the 3. That will be what A1, A2, and other two windings that will be B1 and B2. So it will be usually connected to what four supplies. I think. Let me show you the electrical diagram. That will be easy for you. I think before that we have something step angle, and there is a way talking about step angle, and there is a way how to calculate your step angle. So step angle, as I said previously, what at minimum rotation within a single step, which means what for a given pulse, your stepper motor is going to rotate, and that minimum rotation only called as what step angle. So number of steps per revolution is given by what 360 by a step angle. Suppose if I'm going to take 2 degrees, so what happens? How many rotations I'll get? So 360 by 2, I'll get what 180, which means we'll be having for one revolution, I'll get what 180 steps. Okay. And previously, I think I said something about step size of 1.8. Suppose if I take 1.8, what will happen? So 360 divided by 1.8 will be what? 200, I guess. Am I correct? 360 divided by 1.8. So it will be 200. So that's what I'm saying. So most commonly, the stepper motors, which we use normally for demonstration purposes in laboratories, will have a step size of 1.8 degrees, which means 200 revolutions, 200 steps per revolution. Okay. So this is the way to calculate your step angle. Okay. So you can vary your step angle. So depending upon step angle, you get what number of revolutions, steps per revolution. Okay. Very good. I think this diagram will make you understand much more better. So actually, this we call it as a driver circuit of your stepper motor. So if you say, I've noticed this means here we have what it's a four-phase stepper motor windings, and its interfacing is given basically. So here we have four windings. Okay, that will be what A1. So it'll be having four windings: A1, A2, other two, and there's got B1 and B2. So usually they're connected to what a port. So PA1, PA3, PA0, and PA3. So port 0, you can take any port. Here they have taken, here they have taken a port 1, not port 0. Okay. So whenever a particular port is 1, high, level 1, and PA1 is level 1, means what? Coils. Suppose if 0 and 1 are high, means obviously what? Corresponding coils will be what? Energized, and the motor will be rotated by one step clockwise. Okay. So depending upon the coils which you want to energize. Okay, suppose if I want to energize coil A1 and B2, so which means what PA3 should be level 1 and PA0 should be kept level 1. So again, the motor will rotate by one step. So depending upon similar way, you can make other by using other phases, you can energize water sequential in a sequential manner. And and one more advantage, as I said previously, what we can write assembly language programming for the stepper motor control, so that we can make the motor to rotate both in clockwise as well as what anti-clockwise rotation, both in both the directions. And here's a switching sequence. Yeah, this will make you understand much more better. Okay. So as I said previously, here we have full step and half step. I think hope you remember what is full step and half step. So basic step size of the motor we call it as what full step. And by alternating the switching sequence, the motor can be made to rotate or run with incremental motion of half the water full step. So here it's an example of full step. So here we have what four coils I have: coil 1, coil 2, coil 3, and coil 4. So here the corresponding spirit diagrams are given. So initially, if you have noticed, means what your coil 1 and 2 alone are energized. So it's in highlighted here. So 1 and 2 are energized, which means for coil 1 and 2 alone 1 1, and rest will be water de-energized. Okay, it's not excited. So 0 0. Similarly, second phase, I'm going to energize 2 and 3. So we have to 2 and 3 will be high, and rest 0 and 0.4 will be what de-energized. So fine. And similarly, and third sequence will be is going to be what coil 3 and 4. So coil 3 and 4 has here I'm putting in 1, and rest will be zeros. And for 4, the fourth sequence is going to be what? So like this, if I do means I'll get one complete rotation. Okay, we call it as full step, and the corresponding code I have written it. So it's an 8-bit. So obviously what 1100 stands for C. and 0110 is 6, 0011 is 3, and 10011 is 9. Okay, so this you have to remember, this clockwise. Okay, actually this is nothing but sequence of your switching of your windings. So we're talking about sequence in which your windings are going to be rotated. So keep remember this in mind, because we are going with the help of this only I'm going to write what programming ALP. And so previously we have discussed about full step. Now we'll move see how to write first how to generate code for your half step. So in case of a half step, only one motor, only one coil will be high at a time. Okay. So and there will be a transition between what one from when you want to make another coil high, there should be a smooth transition between your 1 and 2. Okay. So if you notice this 1, 2, 3, 4, you have 8 sequences, whereas in full step you have only one 4. As I said previously, by what? By altering your switching sequence, the motor can be made to run with incremental rotation of half the full step. Okay, so here if you see in means water, so initially coil 1 is alone energized, and now I'm going to want coil 2 to be energized. So before coil 2 to be energized, there is a transition from 1 to 2. So that's what I have written from 1 1. So which means both energized, and after that 3 alone will be energized. Okay, sorry, coil 2 alone will be energized. Okay, this is in step 3. Coil 3 2 alone will be energized again. So from step 3, if I want to move to step 4, actually coil 2 and 3 both will be energized, and then water. After that only water. Coil 3 alone will be energized. So correspondingly, we have to put 1 in the corresponding coils. The same thing will repeat for all the until all the coils are energized. So it will correspond, and also you have to know the codes generated. So 1000 is 8, 0010 is 2, 1009. Okay, so it keeps on repeating. After this, again it repeats. It will come back to what? 8. Okay, so this is a code for your half step. Yeah, coming to your main diagram. Okay, so this is nothing but your stepper motor interfacing. How you are going to interface your stepper motor with 8051. Okay, say anything you are able to understand how it works. Any idea you have? So what is the diagram given? So here we have water. There is a microcontroller here. So this is your microcontroller part, and this is your stepper motor, and in between you have an IC. What is the purpose of that IC? You people would have done quite a lot of mini projects, I hope. SH, நிறைய participate பண்ணீங்க Texas. So I think hope you would have used this IC. Maybe not the exact similar IC number which mentioned here, but definitely you would have used this interface in your circuit. And this is a microcontroller. So forgot about the microcontroller part. Okay, so they are using Atmega 8952, and here we have some IC, and in between we have stepper motor. So what is that? Something in between these two. Okay, forgot about this. Normally, if you want a motor to run, so what IC you will use generally? In any applications where you need a motor, so apart from your controller, so something is required actually to make the motor run. What is that device which tells or instructs the motor to run? So directly microcontroller can't able to what instruct your motor. So in between you need was something. At least you would have typed this part number ULN 2003, and then Google I would have found it what device it is actually. Okay, fine. Second fine. So we need a motor driver circuit. Okay, motor driver IC it's normally required. So this helps you what interface access interface between your controller and your motor. And here we have stepper motor. It has 4 keys given. Sorry. So we have here we have 4 keys and so the 4 keys are interfaced to what? Port 0 here, port 1, not 2, port 0, port 1. Okay, so in order to control for motor operation, so you can use any port 1, 2, 3, it's up to you. Okay, the keys can be used to start So here we have a keys. The keys normally it is used to start and stop the motor. And apart from that, it's also used to select whether you're going to make the rotor forward or reverse direction. And so normally we have in between we having the port pins will be either pulled high and by pressing what will make the port pin low. So we have a key in between. So this key by pressing up and down we can make it pin low and high responder. Okay, and then I will see how it is a program here, program part of it. And moving to the last part, so your program. So how you have assembly language programming for stepper motor. Okay. So initially here I have just written the movement for backward or forward motions. So initially what you have to do is you have to set. We need two ports. Basically, what? How many ports are there in 8051? How many ports are there basically? So basically, we'll be having, yeah, very good. Thank you, Ujwala. I was about to tell the answer. Thank you. So you have basically four ports: port 0, port 1, port 2, and port 3. Okay, so totally four ports are there. So what I'm going to do is, so you have to take any two ports. So initially, you have to initialize one port as an input port, other port as an output port. Okay. So let us take that port 0 as your output port, and you have to set port 2 as your input port. So first case you have to do this, and after this what you have to do is you have to read the status of the keys. Okay, check whether your pin port number, since I said port 0 as a output and port 2 as an input, I am going to check whether that port pin 7 of your port 2, that is normally taken as your start key, is low. Okay, so if it is high, then wait for the start key to go low. Else, if it is low, then we can proceed. Okay, this is a necessary thing. Okay, yeah, correct, Darshini. So, and apart from this, you need, after reading the status, no, so you have to send the sequence. So initially, what are the sequence we got? This, I think, hope I said, you remember this sequence: 0C, 06, 03, and 09. This is the sequence. So what I am doing here is for forward motion. Okay, for forward motion. So I'm going to send this sequence. See here, I am sending 0C, which means I'm sending the sequence for forward rotation to what? Port to A. Again from port A. So I'm sorry, see this 0C is nothing but I got from here sequence, and that I'm sending it to where? Accumulator. From accumulator, what? It is moving to where? Port 1. So which means I'm going to send that sequence 1 for forward rotation to port 1. Okay, that's what is happening. And wait for we have to wait for the motor to settle in the new position. So that's what this A call delays. Okay, so we need, sorry. And this is a complete diagram, okay, where it shows all. Anyway, fine. I'll just go back. So in the you need to, as I said, a delay is required. I hope you remember, as previously, what always a delay is required. Okay, as I said. So the delay is necessary to allow your motor transients to settle down or die out. Okay. So and here is a delay program here. So here I'm initializing what some registers. I'm going to set some time duration. Okay. Fine. And then after sending the sequence, again, what you have to do, we have to send the second sequence. So 06, second sequence for forward rotation to port 1 again. Here directly I'm not moving, I'm moving it to accumulator, and then from accumulator to what? Port 1. So the same process I'm repeating for 4 times, because for different sequences, again, same thing I'm going to repeat for port 03 as well as what? 09. Okay. And his jump back means what? Short jump back, which means back to your water. So which means the motor keeps on rotating for the given rotation. And in case if I want to reverse the direction of rotation, so obviously it's possible. So only thing that what I can do is I'm going to just change a sequence. So instead of sending it as 0C, 06, 03, 09, I'm going to just change the order of the sequence. So 09 first initially, followed by 3, 6, and C. So obviously, your motor is going to rotate in water backward direction. Okay. So like this, you can able to make the motor either on forward or backward rotations. And this is just as you can have a look at it. Small example how a motor will rotate. Just you can have a look at it. So corresponding feed, this is nothing but your ports, and these are being energized, and each time it's energized, it's getting rotated. if you just look at it, means total will be having what 200 steps. So which means each rotation will be 1.8 degrees actually. And there's another example for 45-degree rotations, which means in each steps will be having one complete revolution for 45 degrees. Step angle for 45. So obviously 60 by 45 will be having 8 steps. So for 8 steps, you'll get what one complete rotation. Okay, fine. So with this, we'll stop today.